Okay, share. Okay, are you guys able to see my screen? Okay, perfect. Okay, so I okay, so I'm going to talk about this particular technology called NLIP, or Natural Language Interaction Protocol. It is being designed collectively by many different companies and many different universities. And you can see the name of the companies and the universities on the um, right-hand side. And essentially, at this question, like, you probably may have a question, well, what is a protocol? Why this protocol? And what does it look like? So let me go through those things in detail. So first of all, let's talk about protocols. So the protocol in computer science refers to the set of conventions that machines use to talk to each other. Right now, for example, we are using this Google meeting, and I'm on my machine, you are on your machine, and then my computer is able to exchange the information with the computer on the conference room. In order to do that, these two machines need to communicate, need to exchange information following a certain set of conventions. It is, and those conventions have to be the same one understood by both my machine and the conference room machine, because if they don't, communication is not possible. It is no similar than, say, suppose I am talking in Hindi and somebody else is talking in Tamil, then we won't be able to understand each other. We both have to agree that we'll talk in the same language, where the terms mean the same thing and semantics and syntax are understood by both parties. So protocol is that set of conventions which we computers use to talk to each other. And if you look at the current state of the art, in order for things to communicate, there are many different type of protocols that exist in this day and age. One of the most common protocol convention that exists in the internet is what's called the Internet Protocol, or IP. So when you look at what is connected on the internet, everything on the internet is connected using a protocol called the Internet Protocol, and that's used to talk to each other. Similarly, when you look at this application, the web browser, and you are clicking on the web browser and the web browser is going to other servers, the browser application, whether it be on your phone or the browser application on your laptop, it is communicating to the server on the other side using a protocol called the Hypertext Transfer Protocol, or HTTP. So we have to define these protocols, and these protocols have to be accepted and agreed upon in order for computers to talk to each other. So NLIP is also a protocol very much designed in the same manner to allow computers to talk to each other, or software on the computer to talk to each other in a general manner, in a unique manner. Now, NLIP is designed so that it can take into account the fact that current software is all based on AI. There's a lot of widespread use of AI technologies, which is being used in everywhere, in all spheres of life. And the question, of course, is that when you have all these AI-enabled services that are talking to each other, they can talk to each other using many different protocols. Every company, every project has to define their own protocol that, oh, you want to talk to my AI-enabled service? Talk to me using this protocol. And if you have got too many people talking too many protocols, things will not work quite as well as we like to be. So for example, let's say that if your BITS Pilani, you has 100 students, and those 100 students each are talking their own language or dialect. Well, India has some 680 dialects, so I can imagine the batch of 100 be selected where everybody speaks their own language. Nobody will be able to understand each other. So in order to have the entire community be able to exchange with each other, we have to agree to a convention for a common language, a common protocol. And NLIP essentially is that protocol that we are trying to establish as the common universal protocol that will be used by everybody and and all the AI enabled services. Now, in order to get um, accepted and in order to be used, this protocol has to be standardized. No company standing on their own can try to dictate their protocol or their language to everybody else. Uh, I mean, companies do try. I mean, like, so Microsoft will try its own protocol, IBM will try to define its own protocol, Google will try to define its own protocol, OpenAI will define its own protocol. Every company would try to define and push their own language, their own protocol. But the fact of the life is, it's no different than, say, every state in India wants to promote their own language, but that causes chaos. So, in order to interoperate, someone has to come together and have a standard group. So, industry consortiums are created so that a common language, common protocol can be established. In this context, uh, the work that is defining the NLIP, the Natural Language Interaction Protocol, is being defined in a standard body called ECMA, which stands for the European Computer Manufacturers Association. Now, the name European may seem to imply it's a European thing, but it's not truly a European standard. It's basically a universal worldwide standard. And the European Computer Manufacturer Association has been responsible for standardizing many other technologies. Some of these, those of you who have interest in technology might be aware of. So, for example, if you have heard of something called JavaScript, that is something that is standardized by ECMA. It's called ECMAScript in the official standard. If you have heard of what's called OpenXML, the format in which your Microsoft Office documents or OpenOffice documents or many other documents are represented and the PowerPoint presentations are represented, the XML specification, the OpenXML document specification is also standard of ECMA. And this is the same organization we're working with to define this particular protocol, the Natural Language Interaction Protocol. Multiple companies, multiple universities. I will skip through the names. You can look at the names. And the motivation for that is very simply the following. Right now, AI, or specifically generative AI, is all the norm. The latest buzzword in this is agents, that everyone is saying that, hey, let's create agents. And previous to agent, it was called assistants. And I'm sure that maybe 3 months from now or 6 months from now, instead of calling agents, we'll have probably some supervisors or robots or something else, which will be the term that everybody will be throwing around. But what is regardless of what we call them, agents or assistants or robotic process automation or whatever else you choose, the truth of the matter is that the technology of artificial intelligence is going to be used in many different ways, is going to influence all spheres of our life. And there will be multiple services which have these intelligent agents, AI incorporated functions that will be working in our machines, the machines we have at home, the machines we have at work, the machines within our offices, whether it be government offices or corporations or universities. So if you have multiple of these AI-based services running, which we currently call agents, these agents, in order to talk to each other, can benefit by using a standard common language. This is the same as, like, if we create agents, if we create things, let's have all agents learn how to speak a single language. Whether the language be English or Hindi or Sinhalese or Tamil, doesn't matter. As long as everybody agrees to talk the same language, you can communicate, you can combine agents, you can get maximum benefit out of that. So NLIP is that language and defines that language, that protocol, that agents will talk to each other. The rationale for having a language like this emerges from very common observation. Like, you guys are all students at BITS Pilani, which means that you have left your parents' house, or most of you, and now you are living on your own in the campus, which means you have to set a bank account. Maybe you have one bank account at, I don't know, a local state bank or local Axis Bank. Maybe you are lucky enough and you have 2 or 3 different accounts. You have one account in your hometown, you have one account in Pilani. Now, think of how you talk to the bank branch. Like when you go to walk to the branch of State Bank of India, you probably go and talk to them and tell them, hey, I want to do this, etc. Give me, I need to take some cash out, I need to make deposit a check, etc. Right? When you'll go to the Bank of Baroda or Axis Bank or any other bank branch which you happen to have the same thing, you would basically use the same language, whatever language, like no, and say, do it this way, here is a check, let me deposit it, etc. You don't switch your language to a different one. You don't switch, you don't, it's not the case that if you go to um, uh, State Bank of India, you can only talk Gujarati, and if you go to Axis Bank, you will only be talking like no, whatever Sinhalese. If you are in Pilani, you probably are talking either Hindi or English to the whichever bank you go to. A more simple example: you probably go out and buy your pen from a stationery store. You go out and buy your uh, like clothes from some kind of a mall store. You go and order food from McDonald's or whatever your local favorite, the local dhaba is. When you go there, you just talk to the same. Give me this food. I want 2 order of this. I want this thing to drink, etc. You don't change your language as you go and shop across from one shop to other. Now compare that and contrast that to how computers operate. You go to Amazon.India, the computer, the software on a machine which talks to Amazon.India talks a very different language than when you go to Flipkart. And that computer on the Flipkart has to talk to a very different language. And if you just are using the smartphone, if you look at a smartphone and see how many applications you have on your phone, like no, they keep on exploding. If you are traveling, like you probably have an application from Air India, and you probably have an application from JetBlue, no, sorry, or whatever. Every airline will have your own application on the phone. And the real question is, why do your phone need all these gazillion applications? Why do you need a different application for Amazon than for Walmart, than for Costco, than for Flipkart or any other retailer that is there? The reason simply is that each of these companies that have put forth the retail SIM, they believe that, hey, my clients to talk to me in a different language. This is the language I'll support from Amazon. This is the language I'll support from Flipkart. This is the language I'm going to support if I'm like no, whatever, Reliance Bilra retail shop, etc. And in order to support that language, you need a different app on your phone. Now, there are conventions, there are systems that can make it common, but the fact that there's different things makes life really complicated, both for the phone developers and of course for the application person. So the challenge and the reason it's there is that is the way that, or the how we are generally designing applications is the problem. Now, but if you look at the advent of AI itself can help us create a new protocol, a new common language that everybody talks. And the reason we think that we should define this new language and get it adopted widely is simply the following. If you look at, say, go back 20 years, in 1990, the internet and the web browser came along. Before the web browser came along, before hypertext transfer protocol became the common norm, every server had a client and a server application. Just like right now on your home computer, probably you use the browser 80% of the time, and other applications on your MacBook or laptop only occasionally. On the cell phone, you have got 1,000 applications, or feels like there are 1,000 applications, even if they're not 1,000. And the reason was that in the 20 years ago, when the PCs were the dominant form of things, people used to do the same thing. Every bank will give you their client software. Every retail shop that you wanted to have would have your own thing. And when you created one common software, okay, let's have this hypertext transfer protocol. And then that suddenly made it so easy for people to interact and people to interoperate with each other. Every retail shop could offer the same ST web server, and the same client can be used to go across multiple shops, can go across multiple businesses. Interoperability became much more easy. and one shop can call another shop, etc. And a common language allows you to interact and just unlock the full potential of a connected computer ecosystem was unleashed by one simple thing, the emergence of this protocol, the hypertext transfer protocol. Now, all the benefits of having a common protocol because of the activities and so on then got morphed over, and essentially we took in some sense a step back once mobile phones came around, because everybody wanted different capabilities and to be done. And now that generative AI is around, if we truly want to unlock the potential that, hey, if I've got multiple intelligent agents, AI enabled agents that come from different companies, that come from different universities, some of these could be our own agent, personal intelligent agents that are working and interacting with others. If we really want to unlock the full potential that can be unlocked to society, to business, to economy, we have to have a standard common protocol. And essentially, we want NLIP to be used to unlock the full potential of the AI-based ecosystem that will emerge in the next couple of, I would say, next 2 to 10 years, when we'll have this full potential of this AI-enabled ecosystem in the IT world and in our real life. Right? We want NLIP to be able to unlock this potential, because the fact is that having one single intelligent agent or having one single component is useful. But when you have hundreds of these agents, hundreds of these things available, talking to each other, interacting, opening up new ideas and new things, the network effect just simply multiplies. And that's the unlocking factor that we hope to obtain with this protocol. So now, as we define this protocol has to have certain key features. These features have to be both, some of these features are technical, some of these features are non-technical, but or social constructs which have to be adopted. So technically, this protocol has to be secure and should enable all the various security safeguards, like to maintain your privacy, consumer privacy, data users privacy. It shouldn't prevent people having launched different type of security attacks like denial of service and things of that nature. Why? Because every time we create something for an open ecosystem, unfortunately, in any large enough population of 100 people, there is always one or two bad actors. And if you look around, I'm sure the population at BITS Pilani is great and selected after a long and strenuous process. But even within your group of 100 students or 200 students that you'll see, you'll probably find a couple of bad actors. Not everybody is universally good, despite all the attempts. And if you look at, say, any scale, the set of all politicians in India, you'll find a few bad actors. You look at any set of all all policemen or all government employees, these are all people selected after a fairly rigorous selection process, but you'll find invariably one or two bad actors. And the sad thing is that in this AI world or in the internet space, there are quite a few bad actors. And so when you want to design technology, you have to design technology to guard these bad actors and allow these bad actors to work against each other. The second thing is that we don't live in a vacuum. We can't just say, hey, here is the protocol, here's the language everybody should use, and then all the world will follow it. Just imagine, just to give a political reference, just imagine what happened when Amit Shah said, and hey, we should use Hindi throughout India. Immediately, a few politicians stood up and say, no, that is imperialism, that is not right, you cannot enforce this on top of us, right? The same thing happens in the technical world. If one company says, hey, let's all use this language, 5 other companies will stand up and say, stop it. We don't like your language. We don't like your protocol. We don't like your standard, for whatever reason. Sometimes it is just a not invented here, not my language, not my company type of feature. Sometimes it's based on good, valid reasons. But the thing here is that every protocol, in order to be used, in order to be adopted, you cannot have it be owned by a single company. It has to be something that comes out of the community, that has the support of multiple players behind it, that has the support of a standard organization behind it. And therefore, this protocol has to follow that non-technical paradigm of being standardized in an open forum, in a community, The other thing is that in this current world, there are existing things. The hypertext transfer protocol is a very useful ubiquitous protocol. A lot of security provisions, lot of interoperability, lot of ways to authenticate people have built in and around those protocols. There are protocols and paradigms like resourceful state transfer, which again, if you don't know it, don't worry. They are just existing conventions on how computers should talk to each other. There are other efficient things like message passing protocols, like this quick protocol. There are a whole bunch of existing conventions that have been proposed in the industry. All these technologies that are out there, they have their value. And to the largest extent possible, when we build a new technology, what we want to do is we want to piggyback on the existing technology's capabilities. We want to have everything be done so that like no, the maximum benefit from the current existing technology exploited. You might have heard of that famous dialogue. I think it was from Newton, I believe, which said that the only reason I can look further is that I'm standing on the shoulder of giants. And the thing is that the only way to get forward, only way to make technology that will be useful, that will be adopted, is to stand on the shoulders of the giants being existing technologies. So whatever new protocol we define, if we want it to be used, it has to implement, it has to interoperate, it has to work over all the existing current schemes that are there. And there are multiple transport protocols. There are multiple approaches for authenticating users on the internet. There are multiple security systems that have been developed throughout the course of technical community. There are certain schemes that allow you to get scalability, allow you to operate millions and thousands of requests at some time on the server side. And all of these systems, all of those features had to be preserved on top of the existing technologies. So you don't want to replace the existing technologies, you want to augment the technologies. And of course, other key part is that while we are focusing on the natural language is not the only modality that should be supported. The reason simply being the very simply being the following. When you go to the bank, yes, you talked in whatever, English or Hindi, and you tell the teller what is to be done. But at some stage, you'll show them, here is a check I want to cash. Or if the teller gives you some bills, some rupee bills, you want to look at them and examine them, make sure that they are legitimate bills and not counterfeit, or they are not torn, whatever you need to make certain checks. So the thing is that even as we interact in real life, speech is not the only way we interact. We use vision, we use our hearing, we use sounds, we use other things, and computers similarly have multiple types of information that goes. Computers can interpret sounds, they can interpret video, they can interpret seismic data, vibration data, they can interpret things in so many different formats. And therefore, any protocol that tries to create a universal intelligent interaction has to allow for those agents and for those endpoints to have all of them. And you have to do that in the different language, different communication efficiency. And just like we have in real life language wars among different states, unfortunately, anybody in India is more too familiar about all the language wars that go on in the country, which really should not be there, in the sense that language should be a way to interact and exchange information with each other and promote harmony and peace as opposed to fighting with each other. Similarly, programming languages which exist in the computer, whether it be the C, whether it be Python, whether it be Java, or else even if you come with the modern AI-based paradigm, say that, hey, I want to program in natural language using techniques like vibe coding, regardless of what you do. The protocol should be able to implement in all of these. And the last thing a new protocol should do is start a language war, because just like humans start wars on our own, on human languages, there are subgroups in technology that will create a war on which is the best language and which thing. So any protocol you design has to work across all the languages. So these are the requirements that a protocol has to satisfy. And that's basically what the thing is to be there. Now, this may get into some technical details, but let me just describe at a very high level how NLIP obtains this type of thing. And in order to do that, I'll again tell you a story. Let me go back to the uh, computers, the way that they were designed, say about, I would say 50, or actually more like 60 to 70 years ago. At that time, when people started to design computers, there were many different manufacturers. IBM, my employer, was one of the companies that was a big name in computer manufacturing, but it was not the only one. There were other computer makers. For example, Hitachi was one, Cray was another one, and they had a few other computer manufacturers too. And as it so happened, when in the computer, you have to represent a number like 8, or say you can represent the number 8 as in binary. You write it as 100, where the first place stands for 2 to the power 0, second place stands for 2 to the power 1, third stands for 2 to the power 2, fourth stands for 2 to the power 3. So that if you write a something like 1 1 followed by 3 zeros in computer language, the first one stands for 2 to the power 3, which is 8. So you get 8 plus 0, 0, 0, you get 8 in that way. Now, the one big fight that broke out, or one big conventions that different computer machines did not do in the 1960s, was should you start taking power of 1 from left to right or from right to left? So let me just explain it this way, that if you were writing say the binary left to right, and you have to write 8, you'll write 1000. That is your bits in the computer, which said will be the first bit will be 1, then followed by 3 zeros. On the other hand, if you started to write from right to left, like you could also have 0001. Other computer companies decided that the first 0 should be the unit place, the second 0 should be 2s, third 0 should be 4, fourth 0 should be the 8th, so that you'll write 8 as 0001. Think of it like Hindi versus Urdu. You write Hindi left to right, but Urdu is written right to left, right? And is writing left to right better than right to left? I don't know. It's just basically just the same. And in the computer systems in 1960s, people saw it, and everybody agreed it would be nice if all computers represented things the same way. But as it happened, not everybody followed the convention. So we had machines that had bitmaps in different order on each side. And one of these machines were called the big Indian machines. One of them was called the little Indian machines. And if you go back to those years, I'm sure I wasn't there. Like, it was way before I was born, and way before perhaps many of your parents were born when these type of things happened. I'm sure there would be probably a lot of technical wars arguing whether it's better to represent left to right or right to left. But the honest goodness of the fact is that it didn't matter. As long as a machine was standing alone, who cares whether you are writing 8 as 1000 or you're writing 8 as 0001, right? So nobody cared, except what happened was that at some stage people said, it will be a good idea if I could connect both of these two machines and let these machines talk to each other. They can do more things. They can share work. They can run faster. There's so many amazing things you can do when you start connecting machines as opposed to relying on a single machine. And immediately there was a problem, because a machine that was basically writing on the 1000, when something written as 8 in one machine will become 1 in the other machine and vice versa. So this led to a lot of incompatibility, difficulties in computers talking to each other. This was known as the Big Indian versus Little Indian Wars, which again is derived in terms from Gulliver's Travel. If you remember, if you have read that story, hopefully somewhere in your life journey so far, where if you remember when Gulliver goes into this island of little people, they have a war of the little Indian versus big Indian, because people were arguing which side should the egg be broken on, the boiled egg be broken on the big end or the little end, and they had a war on that. So this was the same type of war on the computers that happened, left to right or right to left. And then when you had to get the interoperability, people came to the convention, hey, what I really want to do is I want to define, just to get a convention on how would information flow on the wire between two computers. So let's agree on this convention that on the wire, it will always flow with the smallest significant bit on the right. And as you go left, bits will be have more significant value. And then everybody, when they receive on the other side, would convert it to their own representation. And as long as you knew that the wire had a fixed way and you knew to inverse it or not to invert it, people could talk to each other. Big Indian machine could talk to little Indian machine. And lo and behold, the battle was avoided. Instead of war happening between computers, you had peace among computers. Multiple computers came together. The network was created and peace and prosperity reigned on the earth. In simple word, अच्छे दिन आ गए थे. Okay. So now we have the same problem here right now, but instead of at the bit and byte level, lower level of computers talk to each other, we now have this problem or this battle which is happening at the application level. And what is this battle happening in this way? Is that if you look at the interface that is exported by any system, whether it be Amazon or Flipkart or thing, they have essentially the convention is that on the wire, you basically define the structure that is going to flow. The structure is generally represented in JSON. It used to before that was to be written in XML, but it doesn't matter. On the wire, everyone says, this is how I accept it. Give me the command, follow this structure. As long as you follow the structure of information, I will be able to understand what you're saying, and I will basically work with you. And what it means is that the client, the wire, and the server, they all have to have the same structured information. And if that's the case, you change the structure, which you'll have to change the structure because after 1 year of running any computer software service, you realize, I should add a little feature here. I should drop that feature. This thing is good. So you always go from version 1 to version 2 of a system. You learn and improve the system. But the moment you learn and improve the system, which means your structure now changes, your previous client does not work. So now you have to upgrade all three of them. So what we are basically suggesting in this NLIP protocol is follow the same lesson that came from the 1960s war of network to host and host to network thing. Define a protocol on the wire, which is just in natural language, like no. And then each side, using their own intelligent and AI, convert it to a local structure. And basically, if you do that, then the wire protocol remains something ubiquitous that can be understood by each of the side, regardless of the structure they're using to do that. And as long as the semantic of the information that is flowing on the wire is understood by both sides, system would work nicely, and then you'll have peace and prosperity throughout. So that, in essence, is the design parameter of the NLIP project. That is how we're defining. And I realize that I'm running out of time. I have to leave in 9 minutes. So let me simply go over to the, at this stage, like I'll not go and define the details of the protocol, but I would definitely encourage you guys to, if you are using, thinking, or building your computer software applications, you're trying to expose clients to each other, you are building AI-based services, what I would like you to do, request you, is go look at this emerging standard. You can go and see the draft specifications. You can see the source code implementation, simple solutions like that at this particular website. You can go to this nlipproject.org website and look at what the system is, what others have done. And what I would like you to encourage is that kick the tires on this protocol, use this language to run your applications, run your software, or if you have got friends and colleagues who are interested in computer languages, promote, advertise, and sponsor that work with them.